energy level diagram for an atom. Usually we have the hydrogen atom, but this is the sodium atom. So the different, usually you see the hydrogen atom has something like 13.6 up here. I think it's 10.2 down here or something like that. But we've got sodium in this case, so it's alright. The same principle applies. We've got an atom in the 3.19 electron volt state, here it is here. It returns to the ground state emitting one or more photons. Calculate the longest wavelength of light that can be emitted by the atom. So it either goes here and here, or it goes all the way down to here. One of those three is going to be our answer, and we've got to put it in wavelength as well. E equals hc over lambda, that's what we're going to be using. So if we want longest wavelength, if we have a really big wavelength, because we're dividing by a big number, we get a really small energy. So long wavelength equals small energy. So this is the one with the smallest energy. So in that case, our energy is 3.19 minus 2.11 equals 1.08 electron volts. And then we just got to do the calculation. So E equals hc on lambda. Rearrange it, we get lambda equals hc on E. I'm going to break my tradition of using only the 6.6 H. I'm just going to go straight and use the 4.14 H because I'm going to use the electron volt E. Okay, but I'm happy that I've done enough practice with different H's. I know when I can use different H's, and I always, well, hopefully always get them in the right place. So this H I'm going to use the 4.14 by 10 to the minus 15 times 3 by 10 to the 8, and because I'm using the straight electron volts, that's why I've got the electron volts H, which gives me 1.150 by 10 to the minus 6, 1.150 by 10 to the minus 6 meters. Okay, which my calculator actually said 3, 4, 5, 6, 1, 1, 5. And I converted that into by 10 to the minus 6. You didn't need to, but it looks much nicer for me. Explain with the calculation why the emission spectra of sodium shows a spectral line at 588.63 nanometers. Well, in that case, we've got the wavelength of light being emitted is 588.63. And so let's work out what that energy corresponds to. Equals hc over lambda. Again, I'm going to go straight to the EV because I want to get my answer in EV. So that's the EVH. I'm going to get my answer straight into EV. 588.63 by 10 to the minus 9, because that's what a nano is. 10 to the minus 9, which gives me 2.11 electron volts. Alright, 2.11 electron volts is from, it's not anything just sitting here. It's a photon emitted when this goes down from here to here and the photon's emitted. So it's from that level to that level. And we have to talk about, because it's emission, so it is going down. So we need to talk about for our last mark. So 2.11 electron volts is from 2.11 electron volts minus 0 electron volts. And this is a photon emitted when an electron jumps from 2.11 electron volt level to the 0 electron level.